So let's say I've got my beam. This is the side view of the beam. And I'm going to weld a piece of pipe to it. So, and that pipe goes 3 feet in from that end. So hook my tape here, pull out 3 feet right there, take my soapstone, my silver pencil, my whatever, make my line on my beam. Okay? Well, where's the tube go? Probably goes right here. So when I make that line, I'm going to make an X where that part goes, because it's going to be really easy to come back later and put that pipe on the wrong side of the line. If all you've got is the line, it's going to be really easy to put that piece or that part or whatever it is on the wrong side of that line. I've seen a lot of people cutting stuff off because the line's in the right spot, the part isn't. So when you lay out a line to put a part down, put an X. What find decision works for you? I like putting an X where the part goes. Put an X where the part goes, and that way when you go get your parts, bring them back, throw them on, you can set it on the right side of the line. I do the same thing when I'm cutting stuff. If I'm cutting parts out of a piece of plate, and I've got my piece of plate, and I'm going to cut a square out of that corner, I put an X on the part I'm going to save, because with a torch especially, my kerf width is 1/16 to an 1/8 of an inch depending on the size of my tip. If I cut on the inside of that line, my part's going to be an 1/8 inch short. So I want to cut on the outside of that line. So this is the part, this is my part, so I want all my kerf to be on the outside of that line. So I'll tell you what side of the line to cut on. Tolerances. Tolerance is a big subject. We talked about it in Blueprint. We're going to talk about it now because it's real, real important. Tolerance is simply how close a part has to be to the drawing's dimension to still be acceptable. Most shops run about a 1/16 of an inch shop tolerance, which means most parts can be about a 1/16 of an inch, either small or big, and still work. But that's not always the case. So let's say I'm going to build something really stupid. I'm going to take a bunch of pieces of plate and butt them up together and weld them like that. And each plate is supposed to be 6 inches. So if my tolerance on each one of these parts is 1/16 of an inch, and the tolerance on my overall piece is my shop tolerance is 1/16 of an inch, can each one of these pieces be a 1/16 long and still have this work? They can. If I'm a 1/16 long on each one of these parts, I'm going to be 3/8 long when I actually stick everything together. And that's going to be over my shop tolerance of an 1/8 of an inch. So like I said, they give you a tolerance, but it's not telling you the whole story. You've got to look at what it has to be overall when you get, when you're done with it, and work backwards from there to see how good your parts actually have to be. In this case, if I'm putting 6 pieces together, it's got to be within a 1/16. Those parts have to be real good, because what I described in this situation is called tolerance stack up. So we have, a plus or minus with every part. By the time you have 5 or 6 of them together, that can be a lot. So tolerance stack up is a big deal, and it's a big deal in everything. But it's something you've got to think about when you're building stuff, because even though you're making the parts to print, you put 5 of them in a row that are all within tolerance, they still might not be right. And you still might have to rework those parts. Sometimes tolerances too, you'll see plus a 1/16 minus 0. It means it can be a little big, it can't be any small, or the other way around. So be aware of that. Fitting. So now you've got all your parts cut, got everything laid out, you're ready to start fitting up. And fitting up is the process of tacking parts together to form an assembly before you weld it out. So you're going to use clamps, dogs and wedges, just all kinds of stuff. There's a huge bag of tricks fabricators have to fit parts up. You'll use all of them at some point. We'll start you out in the right direction here. I really like dogs and wedges. We'll actually I'll show you how to do some in the shop. I'd like to do a dog and wedge project. I'd also like to build what we call a screw dog, which is a screw powered pusher puller for fitting plates up. Start collecting those tools now. A lot of them are home built stuff you can make, because like I said, you'll use them all. One of the big things for fabrication, and fitting is try to get as many parts of an assembly tacked together before you actually start welding it out. Because the more structure I have, the more rigid that structure is, the less likely it's going to be to pull, warp, bend, shrink while I'm welding it out. So get as many parts installed as you can before you actually start weld out. Sometimes you can't get some parts in because you're going to cover welds up with those parts, but get as many as you can in before you start welding. The last thing I'm going to talk about is something that is like, to me, like one of the most critical things about layout fabrication, and that's 3 terms that really define building stuff, and that is square, plumb, and level. Okay? Square means it is perpendicular to another surface. Right? We've all seen framing squares. Hopefully you have a framing square. Square means it's perpendicular to another surface at a 90-degree angle. Plumb means it is 90 degrees to the world. Means it's 90 degrees from gravity. If I'm building, so let's say I've got 2 columns, and a beam on top. Okay? So, plumb means that these columns, I need to plumb those columns, and what that means is they are 90 degrees to the world. That means from whatever surface I've got down here, they are 90 degrees to, and how do we do that? We do that with levels. That's how we plumb stuff in, is with levels. Square, this is a really good example of square. Once I get my columns plumbed, I can throw a square up here to check, reference everything that will check to see if I actually have these plumbed and this is not sitting high or low. If I've got these 2 columns plumbed, but one is shorter than the other, I won't be able to get this square because my beam is going to be sitting at an angle. So it's one way we can check our parts as we go. The other thing is level. I use the term level. I can throw a level up here and check that this thing is level, and that means it is basically parallel with gravity. I can check this, see if it's level, check these, see if they're plumb, and everything should be square at that point. So dimensions, when we're building stuff, dimensions will always try to trick us. I can set these columns in at an angle, and if they're both at the same angle, this is a huge exaggeration, if they're both off the same angle, I can have all my dimensions be right and build a parallelogram, right? But if I've got, let's say I've got another beam here, or another column here that this connects to, I get all my measurements right, my beam will end up hitting this because I haven't built a square structure. I built a parallelogram and it's not right. You can check measurements all you want, they'll tell you you're right. Until you pull a level out, you're not right. You've got to check that stuff. Plumb, square, level, those are terms carpenters use, they're terms concrete workers use, their terms everybody uses when you're building stuff. And you're gonna have to work with those things, so we're gonna talk about them all year long. That's really all I have for today. If you've got any questions, come and find me in the lab or come and find me online. I'll answer them the best I can. Thanks.